Suppose we know what a vector is in terms of some basis b, and we'd like to re-express that vector in terms of a different basis c. How can we go about that? Well, as it turns out, by matrix multiplication. So let's introduce this idea with an example. We have this two-element basis B and this two-element basis C. And we know how to express x in terms of b. X expressed in terms of b is 3, 1. Let's say we can have some relationship between these basis vectors. So b is a basis vector. As such, it is a vector. And it's therefore a linear combination of these basis vectors. Say, for example, that it's 4c1 plus c2. Let's say b sub 2 is negative 6c1 plus c2. So we can express these basis vectors in terms of this basis. Let's now proceed. What we're trying to do is a conversion. We want to express this in terms of C. And there are a few ways we could do this, but let's pick the one that will get us to a definition we want. This expression here tells us that x is 3b1 plus 1 b2. And the coordinate mapping is an isomorphism. Let's apply the coordinate mapping to both sides of this equality. On the right-hand side, we can use linearity to break this apart as 3 times this plus 1 times that. This and this are vectors. They're coordinate vectors. So we've got a linear combination of vectors a linear combination of vectors is a matrix times a vector. And we know what this column and this column are from these relationships. P sub 1 expressed in terms of C is 4, 1. B sub 2 expressed in terms of C is negative 6, 1. So this matrix times this vector equals this. X expressed in terms of this new basis C. And let's do the multiplication to finish out the problem. Let's see. 12 minus 6 is 6. 3 and 1 is 4. So here's what we were looking for. The coordinate vector expressed in terms of the basis C.